My name is Karen Daly and I teach mathematics at DKIT, a third level college in Ireland. This video was produced to further assist my first year computing students with their mathematical studies. At the end of this tutorial, you should be able to find the minimal spanning tree using Prim's algorithm. Enjoy! Let's look at this example. It says the diagram below is a weighted graph showing 7 computer terminals A, B, C, D, E, F, G, with the figures representing the distance in meters between the various computers. So let's have a look at the diagram. We can see here that it's possible to have a connection between computer terminal A and computer terminal E, and the distance between these two computer terminals is a distance of 10 meters. It's also possible to have a connection between computer terminal A and computer terminal B, and the distance between these two computer terminals is 8 meters. And so on and so forth throughout the graph. All this information is displayed for you. Now if we go back to reading the problem, it says required is to set up a local area network with the minimum length of cabling. In graph theory language, I call this initially a weighted graph. It's a weighted graph because I have a value on each of the connections. So for instance, A to E has a weighting of 10. To solve this problem, I'm going to use Prim's algorithm. Right? So the question says, using Prim's algorithm, find. Now what do I need to find? I'm going to need to find what's called a minimal spanning tree. The word minimal refers to the fact that I need the minimum length of cabling. The word spanning refers to the fact that I have to include a connection between all of the computer terminals A, B, C, D, E, F and G. They all have to be connected into one local area network. And it's going to be a tree. A tree is a specific type of graph which has no cycles in it. Because if I had cycles, I would have redundancy within the graph. So the question says, using Prim's algorithm, find the minimal spanning tree, clearly displaying the implementation of the algorithm. And then at the end you're asked what is the length of the minimal spanning tree, which is the same thing as saying what is the minimum length of cabling required. To demonstrate the implementation of Prim's algorithm, I'm going to first display all the information on this graph using a matrix. Now the matrix is going to have a column for A, B, C, D, E, F and G, and it's also going to have a row for A, B, C, D, E, F and G. So here's the structure of the matrix, and I've put in the grid just to make sure you can see exactly where each entry is. Now, if we look along the first row is the A row. And if we look at all the connections up here on the graph that A has, A is connected to B and it has a distance between them of 8. So I'm going to just put in that value, 8. A is connected to E and it has a distance between the two of 10. So I'm going to put in that value there as being 10. Now A is connected to no other point, so what I'm going to do is I'm just going to put in an X showing that there is no connection between A and any other computer terminal. Now I can duplicate this row down the first column because it's the same. A is connected to A, B, C, D all down the column as well, so it's X, there's a value 8, X, X, 10, X and X. What I can also do is I can put a diagonal set of X's all the way down here because obviously there's no connection between a point and itself. Now if I continue filling out my matrix, what I'll discover is that B is connected to E, by a distance 5. You can see that from the graph. There it is. B is connected to D by a distance 2. So let me put that in, 2. And B is connected to C by a distance 3. So let me put that in. I've already got A to B in. There it is there. So it's not connected to F and it's not connected to G. And I can duplicate that down the B column. 8x, 325, x. Now you continue in that manner. C, I'll do one more. C is connected to D by a distance 2. C is connected to G by a distance 2. And they're the three connections. I already have the BC connection in. It's not connected to E and it's not connected to F. And again, I can duplicate that down. X, 3x, and then it's 2x, x, 2. Continuing on for D. D is connected to E by a distance 5. So let me put that in, 5. D is connected to F by a distance 10. And D is connected to G by a distance 5 as well. So if I duplicate that, that'll become 5, 10, 5. E is connected to, let me see, F by a distance 13, and it's not connected to G, so I'll just have a 13 and an X here. And F is connected to G, yes, by a distance 9, so I'll put the 2 9s in. So there's my matrix completed. Now I'm going to show you the implementation of Prim's algorithm. The first step is to choose any node that you're going to start building your local area network from. Now, I'm going to start building it from node A, so I'm going to draw it here, A. Right? Now you can begin from any node, it doesn't matter, but A is just a natural place to begin. Now, on my matrix, I'm going to call the first row, the A row, as being C1. Right? Now the C is going to stand for that it's connected. Right, so it's connected onto my local area network, and the 1 is going to just indicate that that was my first connection. Now A is on the local area network, so what I do on my matrix is that I'm going to cross out column A, because A is now on my network. Here it is here. Right, I've just drawn it here. How Prim's algorithm works is that it starts at A. So if you look up here at the graph here for a minute, right? It starts up here at A, right? And it looks out from A and it chooses the minimum connection coming out from A. So it looks at AE and AB and it'll choose the shortest, the route with the shortest distance. So it's going to choose AB. Equivalently, if you look along the matrix, it's going to look along row A, right? And it's going to look at the figures that are in there. It's going to look at the 8, and it's going to look at the 10, and it's going to choose the smallest of these. So if I put a circle around the 8, that's the first choice it's going to make. So I'm going to put a 1 here, a little 1 outside here, just to show that that's the first choice that it has made. And in making that choice, it has chosen B, right? So if I draw this in here, right, what it has done now, it has connected B onto the local area network with a value of 8. So B is now on the local area network. So what happens is that the column gets crossed out and row B now becomes my second connection. So the 2 stands for the second and B is now connected to the local area network. So the algorithm has A and B connected to the network. So what it's going to do now is that it's going to look out from A. So if I look at the original graph, it's going to look out from A and it's going to look out from B and it's going to look at the shortest route available to it. If you come back to the matrix, that's equivalent to looking at row A and row B. Look at all the values that are not crossed out, right, and find the smallest of these values. Now your choice is between 10, 3, 2 and 5. Okay, obviously 2 is the smallest of these. So I'm going to circle the value 2 and I'm going to put a little 2, sorry I haven't a huge amount of space, a little 2 there, just to indicate that that's the second choice that it's making. In making that choice, the algorithm has chosen to connect D to the network, and D is connected to B. So what it will look like is, if I draw it here, D is now connected, and it was connected through a distance 2. So what happens is you cross out the column that D is contained in, because D is now connected, and you indicate row-wise C3. This is your third connection, your third point that you have connected into the network. Now the algorithm continues in this manner until all of the nodes are connected. So the algorithm will continue in a similar manner. So if we look at the matrix, it will look at the connected rows. So the connected rows are A, B, and now D. It'll look at the values in these rows that are not already crossed out. So in row A, it'll look at value 10. In row B, it will look at value 3 and 5. And in row D, it will look at the values 2, 5, 10, and 5. It will choose the smallest of these values, and obviously the smallest of these values is the value 2. So it circles, I'll circle that to say that I'm choosing that. And in choosing that value, I'm choosing the connection DC. So I'm going to go over here to my graph, and I'm going to put C onto my graph. So C is connected on now with a value 2. Now if C is connected on, what I do is I cross out the column that C is, C column, and I mark the row that C is in as being the fourth connection. So that's C4. Continuing on, I repeat again, I look at the rows that are connected, so that's the first 4 rows. I look at the values in these rows that are not already crossed out. So these values in the first row A would be 10, row B would be 5, row C would be 2, and row D would be 5, 10, and 5. I choose the smallest value, so I'm going to circle that, right? And in choosing that, I forgot to label the last one. That would be my third connection, was the last one, so this is my fourth. So in choosing that one, I've chosen D, and the connection is C to G. So if I write that in up here on my graph, I've now got this connection here, C to G, and it has a value 2. G is now on my local area network, so what I do is I cross G out as a column, and I mark G as being my 5th connection. Okay. Again, repeat what I've been doing for the last few times, and look at the connected rows, look at the values that are not already crossed out, and choose the smallest of these values. So in row A, I have the value 10. In row B, I have the value 5. In row C, I have no value. In row D, I have the values 5 and 10. And in row G, I have the value 9. Now the smallest of these is the value 5. And that value 5 is in 2 places. Now it doesn't matter which of the 2 you choose. It's up to you. So I'm going to choose the BE connection. So I'm going to circle that. And that's going to be my 5th choice, right? And what I have done now is I've connected E into the local area network by connecting it to B. So I'm going to indicate that over here on my diagram. So B is connected to E by a distance 5. Now E is now connected to the network. So what I do is I cross out the column, the E column, and I mark row E as being my 6th connection. Now I only have to do this one more time because all I have to do now is connect up the point F. So what I do is I looked at my connected rows, and there are 6 of them. I look down the column here F, and I choose the shortest path available to me. And the shortest path available to me, I'm going to circle it here, is this path here, 9. 9 is going to be my 6th choice here, and so F is connected to G by a distance 9. So I'm going to draw that in. F is connected to G by a distance of 9. So I'm going to cross out my F column and basically then just label row F as being my 7th connection. So So Prim's algorithm is finished. I just highlighted, hopefully that you can see them better, the numbers with each circle there for you. And my solution, well, I was asked for the minimal spanning tree. Well, as I worked through the algorithm, I actually drew the minimal spanning tree for you up here in the top right hand corner. So let me label it for you. This is the minimal spanning, I haven't got a lot of room, spanning tree. So that is my minimal spanning tree that I was asked for. And I was also asked for the length of the minimal spanning tree, which will be the length of the local area network with the minimum amount of cabling. So if I work that out, I'll write it here. The length of the minimal spanning tree is equal to, so it's just 8 plus 5 plus 2 plus 2 plus 2 and plus 9. And if I add all that together, I will get 28. So it will take 28 meters of cabling to connect up that local area network. And that's the minimum amount of cabling that is required. So I'll just underline that the minimum length, so I'll write minimum here. Minimum. That's an N, sorry. The minimum length of cabling required is 28 meters. What I'd like you to do now is to attempt this exercise. It's exactly the same as the example I went through, except you're starting off with a different graph. So the exercise says the diagram below is a weighted graph showing 8 computer terminals A up to H, with the figures representing the distance in meters between the various computers. Required is to set up a local area network with the minimum length of cabling. Now, this is equivalent in graph theory to using an algorithm, in this case Prim's algorithm, to find the minimal spanning tree. So what you're asked is to, using Prim's algorithm, find the minimal spanning tree, clearly displaying the implementation of the algorithm. And then once you've that done, you're asked what is the length of the minimal spanning tree. So what I'd like you to do is to pause the video and set up the matrix that will display all the information that's contained in this weighted graph. When you have that done, turn the video back on and I will go through the setting up of that matrix for you. Okay, hopefully that went well for you. Let me fill out the values of the matrix. So let me do row A first. So obviously A is not connected to A, so I'm going to put an X here. A is connected to B and the value is 9. A is connected to G and the value is 10. And A is connected to F and the value is 8. A is not connected anywhere else, so I'm going to put X's all along the row. You can duplicate the row going down, so that's X, 9, 3 X's, and 8, a 10, and an X. If I continue on and do row B then, B is connected to A via 9, it's not connected to B, it's connected to C via value 10, it's connected to G via a value 2, so I'll put in the 2 there, 2, and it's not connected anywhere else, so everywhere else I'm going to put in X's. Again, I can duplicate this row coming down the B column, so it's 9X, 10, X, 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 2, X. So if you continue filling it out in a similar manner, you should get this matrix here. So compare the matrix that you've written down with this matrix and see are they similar. So now what I'd like you to do again is to pause the video and begin implementing Prim's algorithm, showing the implementation on this matrix that we have here. I'd like you to begin with A as being your first connection. When you've attempted that, then turn the video back on and I'll go through the solution with you. Okay, then let's begin. So as I asked you to begin with A as being your first connection, so I'm going to draw it up here. A is my first connection. So A is now on the local area network, so I'm going to cross out the column that A is in, and I'm going to mark the first row, the A row, as being my first connection, C1. I'm going to look along the connected row, A, and I'm going to choose the lowest value in this row, and the lowest value in this row is 8. So that's going to be my first choice as a connection, and that connection connects A to F. So if I draw that in up here, A is now connected to F, and the distance is 8. Okay, so F is now on my local area network, it's connected, so I'm going to cancel out the column that F is contained in, and I'm going to call the row C2, the F row C2, as being my second connection. Now I repeat the process again until all the rows are connected. So what I do is I look along my two connected rows, C1 and C2, and I look for the lowest value that's not already crossed out. So on my first row, C1, I've got a value 9 and 10, and on my second row, C2, I have the value 8 and 1. Obviously 1 is the lowest, so I'm going to circle the 1, and that's going to be my second choice. By making that choice, I'm connecting F to G. So if I draw that in, I'll have this F is connected to G via a distance 1. Now G is now connected, so I'm going to cancel out the column that the G column, and I'm going to mark the G row as being my third connection. Now I continue on again. I look at my connected rows. I have 3 of them this time, and I ignore the values that are crossed out, and I look for the lowest value in these rows. So in C1, the only value available to me is 9. In C2, the values available to me are 1 again, 8. And in C3, the values available to me are 12 and 2. Obviously, the lowest value is 2. So what I'll do is I'll circle 2. There it is. And that will become my third choice. And in making that, I'm connecting G to B. So let me draw that in. G is now connected to B, and the distance is 2. Now B is now all connected, so I'm going to cross out the column B, and I'm going to mark row B as being my fourth connection, C4. Continuing, I look at the connected rows. So my first one, there's nothing available to me there. My C4 row, I have a 10 available. My C2 row, I have an 8 available. And on my C3 row, I have a 12 available. I circle the lowest value, and the lowest value is the 8. So if I circle that, that's going to become my fourth choice. So I'm going to put a 4 there. And in choosing that, I've chosen the connection from F to E. So if I draw that in, F is now connected to E, and it's a distance of 8. So E is now on my local area network, so I'm going to cancel that column out, and I'm going to mark E as my fifth connection. Repeating the process again, I look at my connected rows. C1, I have no value available to me. C4, I have the value 10. C5, I have 9 and 5. C2, I have no value available. And C3, I have the value 12. So obviously the smallest of these is going to be my 5. So I'm going to circle this value here, and that's going to be my fifth choice. And that choice is the connection between E to H. So I'm going to put that in, E to H, and the value on it is 5. So H is now on my local area network, so I'm going to cancel out the column, and I'm going to mark H as being C6. It's now connected. Continuing on, again I look at my connected rows. C1 I have no value available, C4 I have the value 10, C5 I have the value 9, C2 I have no value, C3 I have no value, but C6 I have the values 2 and 3. So obviously I'm going to choose the smallest of these, which is the value 2. So I circle that, and that now becomes my sixth choice. And making that sixth choice, that's the connection H to C. So H is now connected to C, so let me draw that in. H is connected to C via a value 2. Okay, so C is now on my network, so I cancel it out and I mark C as being my 7th connection. So repeat the process now for the last time. I only have to look down my row D at the rows that are connected. So C1 I have no choice, C4 I have no choice, C7 I have the choice of 4, C5 I have the choice of 9, C2 I have the choice of X, C3 X, C6 I have the choice of 3. So obviously 3 is the smallest value, so I'm going to circle that value, and that's going to be my 7th choice. So I'm going to put a 7 here. Now, now I've connected D on. By making that choice, I've connected it to H. So I'm going to draw that in up here. So this is connected, D is connected to H, and the value is 3. So I'm going to cross out the D column because I'm now finished, and that's my last connection. That's my 8th connection. And that finishes the implementation of Prim's algorithm. You're asked for your minimal spanning tree, and in implementing the algorithm I've been constructing the minimal spanning tree as I've gone along. It's here in the top right hand corner of the page, so all I have to do is label it if I have enough room. So I'll write it out. It's called the minimal spanning, S-P-A-N-N-I-N-G, tree. So that's the minimal spanning tree that I had been drawing out during the implementation of the algorithm. You're also asked for the length of the minimal spanning tree. And to calculate this, I'll write it here. The length of the minimal spanning tree is equal to, you just add up all the weights that are involved in the minimal spanning tree. So I'll write them all out. It's 8 plus 1 plus 2 plus 8 plus 5 plus 3 plus 2, and that equals 29. So 29 is the length of the minimal spanning tree. So if you're talking about the local area network, right, this is how the local area network would be set up here. This is your local area network, right, that has the minimum connection distance. And the minimum connection distance is what I found down here. It would be 29 meters in length.